Now let's solve the question. A particle is moving along a straight line such that its position from a fixed point is s is equals to 12 minus 15t square plus 5t raised to power 3, where t is in second. Determine a total distance traveled by the particle from t is equals to 1 second to t is equals to 3 seconds. B, the average speed of the particle during this time. Now let's take the first one. Let's write the data given. We have s is equals to 12 minus 15t square plus 5t raised to power 3 meter. Also, the time is in second. Now, before the A, we have time interval. Time interval is t is equals to 1 second to t is equals to 3 seconds. This is the first case that people don't usually understand. Now, time interval, it simply means from 1 seconds to 3 seconds. That doesn't mean we should just jump from 1 seconds to 3 seconds. After 1 second, you will still cover 2 seconds. After 2 seconds, then you will cover 3 seconds. But because we usually solve question and put the first value, put the second value and subtract, and this always work fine for displacement, because displacement is the distance traveled, is the shortest distance rather from between the final position and initial position. That means if you subtract the distance traveled in your final position and initial position, you will get displacement. Now, that because of that, people still mix this with distance, and distance is not like that. Distance is the length of the actual path along which a particle changes its position from its initial position to its final position in a given interval of time. So you will see that the definition of the two is not the same. If you are talking about displacement, that is shortest distance. But if you are talking about distance, that one is the total length of the path you cover from one point to another. That means if it is displacement, it's easy to just put t equals to 1 and t equals to 3 and subtract, and that is displacement. So if for distance, you must do all the total time it covers. That means from t is equals to 1 seconds to t is equals to 3 seconds. The time it covers will be like t equals to 1, t equals to 2, and t equals to 3. Now let us get the position for each time. So before I will now use a coordinate system to explain the distance. And here with the question asked for average speed, not average velocity. We will still do that also. So now in this case we have at t is equals to at t is equals to 1 second. Now what is the position of the object or particle? S is equals to 12 minus 15 brackets 1 square plus 5 brackets 1 raised to power 3. So S is equals to 12 minus 15, because 1 square is 1, so plus 5, and 1 cube is also 1. So S is equals to 12 minus 15 plus 5. Then S is equals to 12 meter. That means at time t1, that is when t is 1 second, the position s1 is 12 meter, meaning after 1 second the object is moving. It stop at 12 meter after 1 second. Now let's see the position of the object at 2 seconds. Now at t is equals to 2 seconds, the particle s2 will be equals to 12 minus 15 bracket 2 square plus 5 bracket 2 raised to power 3. So s2 is equal to 12 minus 15 into brackets 4 plus 5 2 raised to power 3, 8. Then s2 is equals to 12 minus 16 plus 14. S2 is equals to minus 8 meter. Then let's do for at t equals to 3 seconds. Note all the position, so we'll use the positions. Now at t is equals to at t equals 3 seconds, then s is equals to 12 minus 15 times 3 square plus 5 times 3 raised to power 3. So s is 12 minus 15 times 9 plus 5 into 27. So s is equals to 12 minus 135 plus 135. So s is equals to 12 meter. Now let me combine all these positions at the time interval together. So we have seen now that at t1, so at t is equals to 1 second, we have seen that the position is equals to 2 meter. At the second time, at t equals to 2 seconds, the position of the particle is minus 8 meter. Then we've seen it again that at t equals to 3 seconds, the position of the particle is 12 meter. Now let's take the A. We want to find the total distance traveled by the particle from t equals to 1 second to t equals to 3 seconds. Let me use this line to represent my path, the path the object moves. Then here is the origin, that is where the object is starting from. Look at the question. A particle is moving along a straight line such that its position from a fixed point is, now we make this place a fixed point where it's starting from. So the distance covered is the end. We are given this part. Now if the object is starting from the origin here, total distance traveled does not mean you should just do for t equals to 1 second and t equals to 3 seconds and add it together. Then what happened to t equals 2 seconds? As if the object is moving, can the object just move t equals to 1 second? After 1 second, the object skip 2 seconds and move to 3 seconds. You should know this is just interval. So many people just take the interval. You do the first one, you do the next one, you now subtract or add. Doing that, you are just taking the first and the last, and this can only work fine for displacement or average velocity, not distance and average speed. Now even from here I can get my displacement straight. Displacement is the shortest distance between 2 points, that is the final position and the initial position. As we can see from this result, my final position is at 12 meter and my initial position is at 2 meters. Now if you subtract the 2, it's easy to see that my displacement is 12 minus 2, which is 10 meters direct. But if you do this for distance, it will be wrong. But let us assume we are not doing the position of final and initial. Let us solve it the way it should be, normal. Then you can see why it always works fine for displacement to be final position minus initial position, but it doesn't work for distance. Now, at t equals to 1 second, the particle is at a position of 2 meters. That is, at t equals to 1 second, the particle is here. That is, after 1 second, it leaves this place. Let's say this is your house. If you leave your house after 1 second, then you are here according to this part. So you are at 2 meters. Now, the particle move further. After 2 seconds, let me use different line. But everything that happens is still on this same line. So let me use another line first to understand better. Then this same line is the one I'm writing again. Or let me copy it so it will be the same. Now the same okay. Now the same line. After 2 seconds, after 1 second, the particle is there. So let me show. The particle is there. Then at t is equals to 2 seconds, the particle is minus 8. Remember, this side is positive, while this side is negative. Positive, negative. Now at t is equals to 2 seconds, the particle is at negative 8 meters. Now let's call this place. It's an assumption here. Negative, no, it's not drawn to scale. Let's call this place negative 8 meters. That is at t is equals to 2 seconds. That means the particle is not here again. The particle is now here. The particle is now here. So the particle is here before. At 1 second, the particle is here. Then as the particle move another 1 second, meaning at 2 seconds, the particle is here. Then at 3 seconds, the particle is here, 12 meters. So origin, here is minus, here is plus. Now at 3, the particle is at 12, that's plus 12. So let's call this place 12 meters, like this. So now the particle is here. Now see everything in splitted form like this. And take note, I already used the left hand side as minus, so I'm putting it there, and the right hand side as plus. So that means all these ones will be plus, this will be plus. As you can see here, S1 is plus 2, S2 is minus 8, S3 is plus 12. Now let us take everything one by one. So total distance travel now from t equals to 1 second to t equals to 3 seconds. Now let me analyze this diagram. It means you are starting from your house. After 1 second, you cover 2 meters. Then you continue at t equals to 2 seconds. That means here is east. At t equals to 2 seconds, you are already here, west. At t equals to 3 seconds, you are here again. So you are changing your position with time. Now, the interval you guys now consider is that the particle starts from here, it moves 2 meter and now 12 meter. Is it possible that is it going to jump this part? Is it going to jump at t equals to 2 seconds? So the particle cannot just start from t equals to 1 and end up as t equals 3. It's already staged. Interval is t equals to 1 to t equals to 3. That means it will cover t equals to 1, t equals to 2 and t equals to 3. Now if the particle is starting from t equals 2, we can say from t equals 2 to t equals 3, good. But it can't be like t equals 1 to t equals 3. That is just an interval. But in the real calculation, the 3 will come up. Now it's working fine if we just do s3 minus s1 for displacement. Yes, and I'll show you everything here now. We'll see everything that happened here. Now let's take the first part, total distance travel. Now note this point on distance. Note that distance can never decrease. Distance always increases. And for a moving particle, distance cannot be zero. Take notes. Distance cannot decrease, meaning no matter how you walk from here to anywhere, your distance will always increase. Now, as the particle is starting from 2 meter, then it will move to another part. That is why in in distance, there is no negative distance. You rather change it to positive because your distance is modulus of the displacement. I'll do both distance and displacement, but what question asks us to find is distance, not displacement. In short, average speed again, not average velocity. So 2, let me clear the canvas here so that at least we have seen this one. So we don't really need it. So let me move this up. Okay. Now, when the particle is here, after 1 second, it's covered 2 meter. Now I want to do total distance now. Total, that is the A part. Total distance. In total distance, we don't consider minus, but in displacement, we consider minus. Now, what do you notice in this question? As the particle is starting from 2 meter, it moves to this side. Now, from 2 meter to 8, that is, it first move from here to here, 2 meter. Then from this 2 meter, it moves to this side. And here, do you remember, this is your origin, the starting point. Here it means from starting point, it covers 2 meter. Here it means again from starting point, it covers 8 meter, but it's in negative direction. But since it's distance, we don't consider negative. So for distance, we consider positive. That means the distance it covers here will be equal to 2 meter and here 8 meter. From the origin again, it covers from here to here as 12 meter. Remember, this is not drawn to scale. This is the real part, how the object moves. From a fixed point, it covers 2 meter after 1 second. Now after 2 seconds, from the origin, the particle covers 8 meter to the west. At 3 seconds from the origin, the particle covers 12 meter, like that. So now what is the total distance traveled by this particle now? So total distance traveled will be, so we'll start from here. From here to here, the particle covers, so I'm using D for distance, 2 meter. So that is from here to here is at position 2 meter. Now from here back to this place, he has covered 10 meter. Take note. From origin is 8 meter, and from origin to this place is 2 meter. Total distance like this is 10 meter. So that means going backward for 2 seconds, the total distance it covers is 10 meter. From this position now, going backward to this position is 10 meter, as you can see. So from here to here is 2. From here again to this place is 8. 2 plus 8 is 10. That means we have plus 10 meter. So that will be 2. Then plus going this way, that is 10. Now from 8 again, the particle go this way and move 12 meter from here. So now from here we have 8 already. Yeah. Plus, from the origin to this place is 8. From the origin to this place is 12. 8 plus 12 is what? 20. That means plus, excuse me. So I don't need the 2. I've added the 2 to, so I want to remove. So distance now is 10 meter. That is from this position, because the particle is moving from this position back to this position. So the distance covered by the particle is 10 meter here. Plus, then from this position to this position back, this is 8, and this is from here to here is 12. Total is 20. So that means this place is plus 20 meter. So the total distance travel is 30 meter. That means by this particle now, this particle have just traveled 30 meter. So because according to the question, the particle moved from a fixed point, and at 1 equal second is already at 2 meter. Now from this 2 meter, the particle now move towards this side 10 meter. That is 2 plus 8. So and from 8 again, it move this way. So we can easily say the particle move during the second plus third second. So the second here is distance travel, which is 10, and in the third second it traveled 20. So total distance is 13. Now let's talk about displacement here. Let's talk about displacement. Remember, displacement is the shortest distance between the final position and initial position. So I'm not going to say 12 minus 2. Normal, do you know this is my final position? 12. Do you know this is my initial position? 2. 12 minus 2 is what? 10. But I'm not going to do that. For you to see, it's just working fine for displacement, since the definition is final position minus initial position, but it can't work fine for distance. But let's do the same thing as distance. But remember, in displacement we consider negative, because displacement is a vector quantity, distance is a scalar quantity. That is why instead of saying 2 minus 8 here, I'm saying 2 plus 8, because there is no negative distance. So in this case, in the second case now, if I have displacement, though the question did not ask us for displacement, so I'm just doing the displacement. So now for displacements, let us see. Displacement is a distance travel, is the shortest distance between the final position and the initial position. Now, what is the final position here for the first journey? The final position is 8, while the initial position is 2, meaning from t equals to 1 seconds to t equals to 2 seconds first. Now, we move 2, final position is minus 8, that will be minus 8, minus initial position, that is minus 2. So that is the definition for displacement. Shortest distance between final displacement and initial shortest distance between the final position and initial position. As final position is -8, initial position is 2 is here. So the difference, that means -8 minus 2 is equals to -10 meter. Now from here again, the particle is in -8 position and here is 12. So from here, this is now initial position again. This is initial position again, while here is final position. So the distance, the shortest distance there, will be -10 meter, -10 meter, sorry, -8 meter, that is final position, rather 12 meter, minus then initial, that is -8. 12 plus 8, this will be 20 meter. Now total displacement is now -10 plus 20, which is equals to 10 meter. Can you see that the displacement turned out to be 10 as usual? That is the final position 12 minus the initial position. 12 minus 2, 10. But you can't do this for distance. Distance, you must calculate all the total distance it covers in each time interval. Now time interval from 1 to 3 doesn't mean if I want to find my distance I should just say when s is 1 and when s is 2. No, I have to find all the time interval t1, t2, t3 and calculate all the total distance. Now for displacement, you can see it work fine, but here I did not do that. I'm doing from here final position -8 minus 2, that is -10, and also from this position again to this position, this is 12 minus -8, final position minus initial, which is 20. So -10 plus 20, that is 10. You can see now that displacement is final position minus initial. That is just direct. But if you still take direction into consideration, it will fall in the same result. Now, according to this question, the distance traveled is 30 meter, while the displacement is 10 meter. So because some people are doing distance as s2 minus s1, this is wrong. You can only do this for displacement, which we can say is right. As you can see, final position 12 minus initial is 10, but distance is not true. Now, and distance is just AB. Magnitude of displacement is distance. You should take note. Now, with all these things we have analyzed, so I'll use one line to just represent all the journey now. As you can see, I have shown that the total distance is 30. So this is the part. This is the origin. So at t equals to 1, at t equals to 1 second, so the particle is at 2 meter. So the position of the particle is there, 2 meter. So that is from fixed point is there. Now the particle now start moving from here. From here, for t equals to 2, it moves this way. From this point, it moves this way to this point and cover 10 meter. So since at t equals to 2, we have seen that from origin to t equals 2 is -8. So I'm doing everything once now. And from this position, that means it's at another position here, at t equals to 2. Now at t equals to 2 seconds, so from here again it moves another 12 this way. So that means everything here is not changing direction, everything still happen on straight line. So but because our question we have path something like this, that means as the object is moving along that path, but distance is just from one point to another. So we are trying to calculate everything will happen on a straight line. So here, from here again to this final position, he has covered 20 meter. So because at this point we can call this place 8, and from the origin again 12. So this is it. Now that means at, if I use time, for example, if I use time at 1 o'clock you leave your house, you will have covered 2 meter at this point. Then at 2 o'clock you are at this position, you have covered 10 meter again. And at 3 o'clock you are here, that means you cover 20 meter. That means your total distance is 2 meter from your house, and from here again 10 meter to this place, you have covered what distance? The total distance is 12, like that. But now what we are doing is that this position is where you are starting your journey. So just that from your house you stop here, so we are now starting from 2. That means from 2 to this place you have covered 10 meter. And at t equals to 3 seconds, I'm trying to explain here so that you will not think boy is starting from its house and reach here 2, and from here again move 10, that everything should be 12. No, the question said this is a fixed point. At this point we shall know that the object is here. We just know that the object is at this position, but we know it's coming from somewhere. Now we are starting our calculation, our movement from this position, not from the origin. So according to the question, so after 1 second, because the time is 1 second, so we start at t equals 1 second, not t equals 0 second. So if t is 0 now, that means you are here, but at t equals 1 you are at this position. That is what we are doing. So now from this position you now move towards this side. At 2 seconds you are here again, but that means you cover 10 meter. So your distance from here to here is 10 meter. So from here again you move another 20 meter at t equals to 3. So that means your total distance travel is 10 plus 20. But displacement we need to consider minus, as I show you that time. So for displacement it will be final position here, that is minus 8 minus 2. So here will be minus 10, and from here again minus 8, you stop at 12. So here will be 12 minus minus 8, which will give us 20. Minus 10 plus 20, that is 10. We've shown that. So A now, we've already seen that total distance, because that is what we need. I'm only explaining displacement. So total distance traveled, total distance traveled by the particle is equal to 30 meter. B, total average speed. Again, this is another point. Average speed is not average velocity. Average speed in an interval is equals to total distance travel divided by the time interval. Take note, your average speed depends on your time interval, and it depends on the total distance. But average velocity depends on your average speed, and average velocity depends on your displacement. That means average velocity will be displacement over time. Take note. But what we are doing is average speed. Anytime you have average speed, speed is a scalar, so it depends on distance. Average velocity depends on displacement. So now that means in a given interval, average speed is total distance divided by the time interval. So now that means we have Total distance here should be 30 divided by the time interval 2. How do we know the time interval? That is 3 minus 1. So 30 minus 2, that is 15 meter per second. So but if it is average velocity, you will not use the total distance, you will use the displacement, and the result for displacement is 10 meter divided by 2, which will give us 5 meter. Now this 5 meter is average velocity, not average speed. Take note. So now that means we have solved the question. Take note of all the points and try to understand the analysis. Time interval, the points I can give here is that time interval does not mean the object will jump from one to the other interval. That means if I say time interval is from t equals to 1 second to t equals to 4 seconds, that doesn't mean you should do t equals to 1, t equals to 4 to find distance. You must do t equals to 1, what is the position of the object? At t equals to 2, what's the position? At t equals to 3, what's the position? At t equals to 4, what's the position? Then add everything together. If it is distance, don't consider minus. If it is displacement, you should consider minus. So thank you. So note that you will just say t is 1 to t is 4. I'm only emphasizing on this because people do this for distance and this work fine for displacement, as I show. Final position minus initial position, that is displacement. Because if you add everything considering a minus, it will be the same. Thank you.